Okay, the next section, chapter 2, section 1, we're actually going back a little bit, and we're going to talk about functions in the vertical line test, whether an equation is a function. Okay, first of all, let's talk about a relation. A relation is just a set of pairs of inputs and outputs. Okay, well, what's an input? An input is x values or the independent variable. You can choose any input to put into your set. However, depending on what input you put in, you have your output, also known as the dependent variable. So you have your independent variable, which is the input, and your output, which is the dependent variable. These are words that you need to understand, okay? We can represent a relation many different ways. We can represent them as an ordered pair, okay, where my x is the input and my y is the output. So if you look here, x is always the input, y is always the output. Depending on what x we choose, there's always going to be a y assigned to it. A mapping diagram is another way to do it, okay, where you have a circle and you have arrows pointing to it. So here, -3 goes to 4, 3 goes to -1, 4 goes to -1 and 3. A blank to pair each input with an output, an arrow to pair each input with an output. Another way to show a relation is a table, an XY table, where your X's are your inputs again, and your outputs are your Y's. And if you notice, if you look at all of these things, okay, they are all the same relation. -3, 4, 3, -1, 4, -1, 4, 3. Same thing, -3, 4, 3, -1, 4, -1, and 4, 3. Same thing here in the XY table, and then we have a graph. If you were to read this graph, the way it is, this point would be -3, 4. Where have I seen that again before? Well, it's in all of these. It's here, and it's here. Okay? It's just a different way to represent the same relation. Okay? These are all relations represented as an ordered pair, as a mapping diagram, as a table of values, or a graph. If I asked you, please take this graph, this relation, and write it as a table, you would make an XY table. If I said make a mapping diagram, you would be able to make a mapping diagram of the same set of information. Okay? Now, let's fix this again. A domain is all the inputs or the independent variable, okay? And graphically, we read this from left to right. It's all the ordered pairs that are x's, and the range is a set of outputs or the y values of an ordered pair within a relation, graphically read from the bottom to the top. So if I were to look at this, identify the domain and range of the function of the following, if you remember what we just said, we said all the x values are a domain, all the y values are range. So that's it. Okay, so I'm going to look at this and I'm going to say, okay, what is my domain? Well, I have a 3, a 7, a -2, a 1, and a -6. I like to put them in order from least to greatest, most likely on Math Excel. You're going to have to do the same thing, so you might as well do that on your homework or when you're practicing. So the smallest is going to be -6, and then I have -2, and then I have 1, 3, and 7. And that's my domain. The range is all the y values. So the range, and if something repeats, you don't have to write it twice. So I have my smallest one of -3, then I have 4, then 6, 4, 6, oh, I missed 1. There we go. I missed this one right here. -3, 1, 4, 6, and then 10. Okay, that's my range, and that's it. Function, a relation in which an element of the domain corresponds with exactly one element of the range. What does this mean? The x value can only choose one y value from the range. So what we have to learn is we have a relation, okay? We have where x's and y's relate to each other. Now we have to decide if the relation is a function. And how do we know if it's a function? Well, every single x has only one y, okay? We don't care about the y's, we just want to make sure the x's are good. So here's a question we ask ourselves in order to determine if a relation is a function. Does the x value repeat? And if it does it go to the same y value? Okay, You have to remember that. Write that down. Does the x value repeat? If no, then yes, it is a function. Okay, if yes, did the x value choose the same y value? If it does choose the same y value, then yes, it's a function. So if the answer here is yes, we say yes, it's a function. Okay, if the answer is no, then it's not a function. You have to remember that. We're going to do some examples here in a minute. So, for example, who in the class wants to eat ice cream? Okay, since we don't have a class sitting in here, think to yourself, all the people in your class, who would want to eat ice cream? Who would want to eat candy? Okay, who would want to eat both? Well, if everybody in the class chooses either candy or ice cream, we are a function. However, if one person in this class, okay, let's just pretend I have a classroom full of kids, if one person chooses candy and ice cream, they throw some candy on top of their ice cream, our class is no longer a function. Okay, if we have one or the other, we are a function. As soon as somebody takes some candy and throws it on their ice cream, we are no longer a function. Okay, so who in the class wants to eat both? Since people are here, so we chose both. Okay, you have to choose only one, not both, to be a function. And we'll do an example. Okay, so look at this one. Is the relation a function? Here's my domain, here's my range. Ask yourself the question. Do the x values repeat? So here I have -3, -2. -3 doesn't repeat. 0 doesn't repeat, and 4 does not repeat. So the answer, no, it doesn't repeat. So yes, this is a function. Ask myself the question. So here we have 4, -1, 8, 6, 1, -1, 6, 6, and 4, 1. Does the x repeat? So I'm looking at 4, 8, 1, 6, and 4. Yes, I have a 4 here and a 4 here. So since the answer is yes, does that 4 go to the exact same y value? Well, here 4 is with -1, and here 4 is with 1. So the answer is no. So yes, the x repeat. Did it go to the same y value? No. The 4 chose 1 and -1, therefore it's not a function. 4 ate ice cream and 4 had candy, so it's not a function. Okay, is this relation a function? Well, 2 goes to -3, 2 goes to 3, and if you ask yourself, well, did the x repeat? Yeah, there it did. Did it go to the same y value? No, it did not. Yes, x repeated right there with my 2. I have 2, 3, and 2, -3. Did it go to the same y value? No, it did not, because it went to 3 here and it went to -3 here. Therefore, this is not a function. So let's look at this one. -7, 14, 9, -7, 14, 7, and 7, 14. Does the x repeat? Well, -7, 9, 14, and 7. No. Okay, does the x repeat? No, it does not. Then it is a function. Okay, and you have to learn that path. Does the x repeat, yes or no? If it does repeat, does it go to the same y? Okay, so look at this one. 4, -3, 6, 2, 1, 0, 4, -3. Does the x repeat? Yes, it does. I have 4, 6, 1, and 4. Right here I have a 4, and here I have a 4. However, does that 4 go to the same y value? Well, here it goes to -3, and here it goes to -3. Yes, it does. So is it a function? Yes, it is a function. Since it repeats and goes to the same. As soon as I make this one of these two a different number, the y value a different number, it's no longer a function. But if 4 chooses the same y, it's still a function. Now, another way to do it, let's say we have a graph, and we need to decide if the graph is a function. We want to do something called the vertical line test. If we remember what a vertical line is, it's a line that is straight up and down, okay? The test is to make sure the x values choose only one y. So what you're going to do is you're going to take this vertical line, here's my vertical line right here, okay? My function is in red. Let me erase that line I just made. Okay, my function is in red, and I'm going to take this vertical line and think to myself, okay, does it only hit the red line once all the time? And the answer is yes, okay? It only hits one time. That means, yes, this is a function. If it crosses the graph in more than one place, then it is not a function. If it only hits once, then it is a function. So when I bring this back and forth, we can say, yes, this is a function. okay? Now let's look at another one. Oh no, let's just say, I'll show you an example of one that's not a function, okay? If you have something that looks like this, a circle, okay? As soon as I bring my vertical line test into that, as soon as I come across, look, here it hits once and here it hits twice. So this is not a function, okay? And that'll give you another example.